wants us to do, really what you do is you'd have to send error bars, basically wiggle the ruler so that it goes through all those points. IB wants you to use the first and last point. This seems like a reasonable thing to do. So take once you've drawn your little error bars, take it and make the steepest line you can, just like we always do. Just like we always do. And then draw the least steep line that you can draw. There you go. So this is not exactly rocket surgery. What I think you're going to do, half a square. They're half a square is wide. They span a whole square because they go up and down a half a square. Up a half, because each square is 40 and our uncertainty was 20. Right? Now, what we need to do is we need to conclude, right? So what I want you to do is I want you to read your graph. I want you to read this number off the graph. And this is something that for some reason in years past, I say this, but people just don't understand this. So if you look at my graph, this line here looks like it's minus 220, 230, 240, almost, oh wait. Minus 210, minus 220, almost minus 230, right? I can almost read the graph, right? So I don't know, maybe minus 227, right? Isn't that the highest it could be? Right? So you're going to read your graph, see where you ended up, because I'm not especially good at this. You're going to read that, you're going to read this. You're going to look at the graph and get a number just like I just did. Okay? So read your own graph, keeping in mind that every square is 10 degrees Celsius, and that we're going negative, so it's weird. Okay? Yeah, I want you to write that down or something like that, right? And then you're going to write a conclusion, okay? And you're going to say, we're going to do all these conclusion-y things that we can do. So what's the first thing? Do we conclude? Yeah, we conclude, right? So we need to say, my results were that the absolute zero was, and whatever it was, what's your best guess? You're going to say a number there, right? You're going to talk about one number. There's number 1, right? Okay? And which is reasonably close to the accepted value of 273 minus 273.15 determined by Lord Kelvin in his famous experiment or something like that, blah, 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 right? Okay? The uncertainty allows for an extrapolation upper limit of minus 227 or whatever I got, right? And a lower limit of blah, blah, blah. And so the accepted value lies well within this range. I think that's about, we pretty much said everything we can say there, don't you think? The value we got was something, right? This is reasonably close to the value, blah, 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 right? Yeah? Okay. And really we're supposed to provide for IB a citation for that. We're supposed to cite, and I don't know, what do we do? Do we cite, in this case, Lord Kelvin's original work? Okay? I don't know. Okay? You could, one would think we could say the well-accepted value of 273.15, but they say, you know, if you're comparing it to a value that we know, you got to have a citation. So if you're IB, I suppose you got to do that, you know. Find out what that was. Look up Kelvin. It's Lord Kelvin to you. Okay? Now, we're almost done. We're a third of the way done with our conclusion. So what do we do? No, what do we for our conclusion, right? We got to talk about, on the however, there were many sources of error for this lab. The thermometer used, blah, 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 you know, maybe perhaps was not calibrated. Maybe we didn't wait long enough to, although I think we waited, but you know, we might not have waited long enough, might not have all been the same temperature. Gas might have escaped from the container. What else? What are their sources of error? The scale might not have been read directly. The scale was loose. You know, usually when they give completes, people have talked about 2 or 3 sources of error and then how you would remedy that, right? Sources of error and then remedy. Yeah? Should you have make a nice data table too? Make a nice data table. I'm married to Shannon Mary O'Reilly. We definitely have plans for St. Paddy's Day. No, we didn't. Caleb wanted to do that, and I like checked as like a slacker, and they were like already closed. But 30,000 people running. Yeah, I've been in the Starlight Run where I think like 5,000 people run. That's like a lot of people. 30,000. Wouldn't you feel like a cattle in like a cattle shoot or something?
How many people run in Portland there?
I don't know.
Do you run it in Portland?
No, I've never run a marathon.
Really?
I'm just a beginner. $20.92. Zero is kind of a dilemma, right? This is why they invented Excel. For the people watching this at home, this is a device that holds a fixed volume of gas. We close the valve and we put it in hot water, room temperature, boiling hot water. Then we let it cool down, and we got these data points here as it cooled. And then we did ice water. So pretty fun. Was it fun? Did you guys have fun? Shoo. Yeah, it's pretty fun. It's pretty fun.